Hello everyone, welcome to Chemistry Stars. Today I am going to teach you the free radical mechanism of addition polymerization. Addition polymerization is also known as chain growth polymerization because we have already learned that in addition polymerization, small monomer units join together repeatedly to form a long chain of polymer, right? So, while forming that long chain of polymer, chain growth takes place, and that is why it is also known as chain growth polymerization. Now here in the NCERT textbook they have shown the free radical mechanism of the formation of polyethylene polymer from ethylene monomer. So I am going to teach you that example itself. So before going into the mechanism, let me tell you some points. See here, in addition polymerization, the monomers which we are using. Okay. We have already studied in addition polymerization, the monomers should contain double or triple bonds, right? So in such monomers only the addition polymerization takes place, right? So if you hear the word addition polymerization, the monomers should be alkenes because the alkene contains double bond, right? Alkynes because they contain triple bonds. Dienes in it, double bond is present, right? So the monomers should be alkenes, alkynes or dienes. And in order to initiate the steps which are there in this mechanism, we need a catalyst, or as this catalyst initiates the step, we call catalyst as initiator also. Okay, initiator. And the catalyst which we are using here is benzoyl peroxide. Okay, here catalyst can be a peroxide. Catalyst can be a peroxide catalyst. And the catalyst which we are using here is benzoyl peroxide. See, the word peroxide means it should contain OO bond. Okay, this oxygen-oxygen linkage is present in peroxide, in every peroxide. So if you hear the word peroxide, you have to remember there should be a OO bond like this. And also you can use, here we are using benzoyl peroxide, also you can use any peroxide like acetyl peroxide or third butyl peroxide like this. Okay, and if I talk about the structure of benzoyl peroxide, see, benzoyl peroxide means without any doubt you can put a OO bond like this. Benzoyl peroxide means the benzoyl group should be present, and the benzoyl group is benzoyl means C double bond O. Benzoyl means here a phenyl group, right? Also this is C6H5, so I can write like that, or I can write like the C6H5 COO and C double bond O, here also like that, C double bond O C6H5. This is benzoyl peroxide catalyst which we are using. Fine. Okay. Before that, let me tell you one thing. If you haven't subscribed to this channel yet, please do subscribe and press the bell icon to get notifications. Okay. So in the whole process of this mechanism, we have 3 steps. The first one is chain initiation step, second chain propagation step, third chain termination step. So now we are going to discuss the chain initiation step, and here what happens is that formation of free radicals takes place. So now let us see how they are formed. This is benzoyl peroxide, a catalyst, or you can say it is the initiator. So first of all we have to consider the initiation, right? Okay. So let us look how it works. So here the whole mechanism is done under the presence of light, that is light or heat. Okay, so when we apply light or heat, this catalyst is not too much stable. Okay, this is not a stable, or this is not a very good stable catalyst. So what happens is that this bond is very weak, peroxide linkage. So here Okay, this bond. Consider this bond, and in presence of light or heat, homolytic fission takes place. One electron shifts over this oxygen atom and the other electron shifts over this oxygen atom, which leads to the formation of free radicals. That is here C6H5 CO. Oh, this is a radical formed, and here as a result of homolytic fission, two such radicals are formed, right? One from here and the other from here, and the name of this radical is benzoyl radical. Okay, benzoyl radicals are formed. Fine, and this is not the final step. See here, benzoyl radical can also undergo, this is also not too stable. So this bond between, okay, this C double, this bond, here also homolytic fission takes place. That is, one electron shifts over here, the other electron shifts over here, and this leads to the formation of two C6H5 radicals. 2 C6H5 radical means, what is this? Phenyl radical. C6H5 means it is phenyl, and here phenyl radical, and 2 carbon dioxide gases evolved. 2 moles of carbon dioxide gas are evolved. Okay, and what we want is this phenyl radical. Note it down. So now what happens is that this phenyl radical combines with ethene, which is here we are dealing with the, see here we are dealing with the polymerization of ethene. N number of ethene molecules on polymerization gives, okay, this equation you have polyethene. This equation we already have learned, and we are considering this example. Okay, we are considering the mechanism of this reaction. So here phenyl radical combines with ethene, CH2 double bond CH2. This is a free radical, right? So what happens? Ethene also undergoes homolytic fission. Sorry. Okay, here we have double bond. So ethene, this bond shifts towards this, and this homolytic fission takes place. This leads to the formation of what is, okay, this itself CH2 radical. This is radical. Now I can write here like this. Okay, the radical is combining with C6H5. Okay, now these radicals are not stable. When they combine, what happens is that this electron and this electron join to means they together form a covalent bond, right? So C6H5 CH2, just combine them and write to radical. This is again a radical. Now the second step is known as chain propagation step. Here the chain propagates, and here we are using the product which is formed from the previous step, that is chain initiation step, right? This is the product which we got after the chain is initiated. So it combines with ethene molecule, right? It combines with a new ethene molecule. Second step, what happens is that this radical combines with another CH2 double bond CH2. Here homolytic fission takes place, and okay, these two combines in order to form a product like this CH2. A bond is formed between these two, right? A new bond is formed, and this is again a radical. Here you can clearly, it is visible that the chain is elongating, right? Here the comparatively the chain has elongated. That is why it is known as the chain is growing, right? That is why it is known as chain growth polymerization. Fine. So like this, we are using n number of ethene molecules. So when n number of ethene molecule combine with such radical, what happens is I can simply write here n. Okay. So this is okay. This is how the chain propagates. Now the third one is chain termination step. Okay. Now, the third step is chain termination step. Here, termination takes place, and in order to terminate a step, what is the thing is that free radicals should combine. Okay, free radicals should combine. So, this is a free radical which we got from the chain propagation step, right? So, this radical combined with another radical which is similar to this. See, here this is not only one radical, okay, like this. In that reaction vessel we can see many free radicals like this. So this radical combined with another radical which is similar to this one, that is, I can write CH2. This is that radical, okay, which it combining CH2 N times C6H5. These free radicals are combining together to form, I can write C6H5 CH2 . See, this join together to form a bond here, right? So I can write a bond between these two. C6H5, and this is not a radical, right? These free radicals are combining together to form the polymer molecule like this. We can remove the C6H5 by using suitable methods, and thus we get what? The polymer, right? That is, polymer is polyethylene. So this is how this whole mechanism takes place. Hope it is clear to you. So I can say here radicals combined, okay, that is free radicals. These free radicals combined, and the chain is terminated, right? Chain is terminated in order to form the polymer. That's it. So guys, one thing which I want to tell you people is that we have a Telegram channel, Chemistry Stars. I have provided the link of that channel below in the description box. So if you are interested, or if possible, you can check the description box and you can join our public Chemistry Stars Telegram channel through that link. What is the benefit is that I am providing MCQs and MSQ type of questions in that channel. So you can answer to such questions by giving your polls. Also, it will be very helpful in order to boost your concepts in chemistry, and also it will help you throughout in your academics, and also to boost chemistry concepts. So if possible, you can join to that channel, and or not only questions, I'm also providing notes related to the topics which I'm covering in the YouTube channel. Okay, so you can join, and if you want if you have any doubts or feedbacks, you can comment in the comment section, or you can chat in that Telegram channel. So that's it. And if you haven't subscribed this channel yet, please do subscribe, and if possible, please share with your friends also. So let's meet on the next video. Till then, bye bye guys, and take care. Okay.